Hello everyone. So students, today we will study about the Coulomb's law in vector form. If you remember in our last video, we have talked about Coulomb's law. We have derived an expression for Coulomb's law, but we have not discussed about the Coulomb's law in vector form. Okay. So here in this video, we will discuss about the Coulomb's law in detail, that is in vector form. Okay. So now let us just see the diagram here. Okay. There are two charges Q1 and Q2. Okay. With their position vector R1 and R2. I believe you must know about the position vector, guys. Okay. So what is position vector? Position vector is what the directed distance from origin to that particular point. Okay, is what the position vector. Okay, guys. Now suppose that charges Q1 and Q2 are similar in nature. So there will be force of repulsion. Yes or no? So what is the force at Q1? What is the Coulombic force at Q1? So let the Coulombic force at Q1 is, due to Q2 is F12. Okay, force on 1 due to 2 is nothing but 1 by 4 pi epsilon naught into the product of the charges. What is that? Q1 into Q2 by distance. What? Let distance is here is what? R12. Yes or no? This is what distance. So R12 whole square into R12 position vector. Sorry, R12 unit vector. So how do we represent the direction? By putting the unit vector. Yes or no, guys? So I can write here that R12 magnitude is what? R. And what is the unit vector formula, guys? Unit vector is nothing but the vector by its magnitude. So I can write R12 is nothing but R12 vector by R12 magnitude. Yes or no? So just explain, F12 becomes 1 by 4 pi epsilon naught into Q1 Q2 by what? This becomes R. So this is R square into R12 vector by R. Yes or no? Or I can write 1 by 4 pi epsilon naught into Q1 Q2 by R square. Sorry, RQ into R12 vector. Yes or no? This is what? F12. Similarly, guys, we can also find that what? The force at 2 due to 1. What it become? This is F21, which is nothing but 1 by 4 pi epsilon naught into Q1 Q2 by RQ into R21. Yes or no? The direction just reverse because this is what if I'm going to find the force on this direction, at 1 the direction is along this. If I'm going to find the force at 2, direction is along this, because both are what? Similar charges, and we know if the charges are similar, then there is a force of repulsion. Agree? So this is how you're going to find the force or the Coulombic force in vector form, guys. So you find here, guys, one thing: F12 is nothing but minus of F21. Remember, we have discussed about it because the forces are equal but in opposite. How? Because we know R12 is just minus of R21. Yes or no, guys? So if you can able to find the force at one charge, so just take the negative of the other is what the force on next charge. Yes or no, guys? So this is what the force on the Coulombic force in vector form. And guys, remember the vector or the direction. Vector means what? Direction. This is what the magnitude, and this is what the direction. Okay, so how do we represent direction, guys? We represent direction by unit vector. So I just break the unit vector in terms of vector by its magnitude. So guys, remember all the two things here. F12 is equal to minus of F21 as only because R12 is equal to minus of R21, and his one concept comes as the concept of position vector. Yes or no? So this is what the Coulomb's law in vector form. Then guys, I'm talking, let us discuss about the what is the meaning of permittivity. Okay, so remember, guys, when two charges are placed in any medium other than the air, the force between them is greatly affected. Now you see here, epsilon naught is what? Force is inversely proportional to what? Epsilon naught. As we know, epsilon is equal to epsilon naught into epsilon r. You remember this, guys? Okay, epsilon is equal to what? Remember, epsilon is equal to epsilon naught into epsilon r. Epsilon naught is what? Permittivity of free space, and epsilon I is what? The relative permittivity. Yes or no? So if relative permittivity is not given, or if it's 1, then epsilon becomes epsilon naught. So you find the force is inversely proportional to the permittivity, guys. Yes or no? So if permittivity increases, force reduces. Okay, so this is all about the permittivity, guys. Now next we'll discuss about if what happens if there are multiple charges are there. Here you find that there are only two charges, guys. Yes or no? Only q1 and q2 are present here, over here. Yes or no? Now we can, guys, we can further reduce this expression as f12 is equal to 1 by 4 pi epsilon naught into q1 q2 by rq into what is r12 is nothing but r2 minus r1. Yes or no? This is the final formula. Yes or no, guys? Now what happens if there are multiple charges? You can see here there are only 2 point charges, q1 and q2. Now what happens if there are multiple point charges? So you find here, guys, just look at the diagram. Here there are three charges, q1, q2 and q3, and we need to find the force on q1 due to q2 and due to q3. So how do you find, guys? So the concept which, I mean, if there are multiple charges are there, so we use a concept called concept of superposition. Okay, you remember this, guys. The superposition means what? The principle of superposition states that when a number of charges are interacting, the total force on a given charge is the vector sum of all the forces exerted on it due to all other charges. The force between two charges is not affected by the presence of other charges. Now suppose I want to find the force on q1 due to q2, then I find the force on q1 due to q2, then again find force on q1 due to q3. I'll get two forces. Just find the resultant of that particular forces is what? The force on q1 due to these two charges. Okay, so now, guys, let us assume here the force on q1 and the charge q1 and q2 both are similar nature. So what is the direction of force on q1 due to q2? Is obviously this direction. Yes or no? Yes or no? Similarly, guys, now suppose q3 is also similar charges. Okay, so q1 and q3, so I want to find the force on q1. So what is the direction? Is away from q3. So this is what the direction of f13. So you find the resultant of f13 by the triangle law or the parallelogram law of vector addition. Okay, now the question is, how do you find the force on q1? So force on q1 is nothing but f13 due to 2 f12 is equal to what? 1 by 4 pi epsilon naught into q1 into q2 by distance is what? Here r12 square into r12 unit vector. We have just explained before. Yes or no? So now just break it as we know. Here 1 by 4 pi epsilon naught into q1 q2 by what is r12? Let this is r, so this is r square into this is r12 vector by r12 magnitude. Now this is 1 by 4 pi. You see here, guys, 1 by 4 pi epsilon naught. Yes or no? Into q1 q2 by this is also r, so r into r square is what? rq into r12 vector means r1 vector r2 vector minus r1 vector. Yes or no? This is what? f13. Similarly, guys, can we find so this is f12. Can we find f13? So f13 is nothing but 1 by 4 pi epsilon naught into what, guys? q1, the product of charges, so q1 into q3 whole divided by what? R square. So r of square, so r13 whole square into r13 vector. Yes or no, guys? It's a unit vector. Yes or no? Now which is equal to 1 by 4 pi epsilon naught into q1 q3 whole, let this is also r. Okay, from 1 to 3 distance is r, so r square into r13 vector by his r13 magnitude. So this is nothing but what, guys? 1 by 4 pi epsilon naught into q1 q3 whole divided by rq, because this is r square, this is also r, is what? rq, and this is r3 minus r1. So this is what, guys? f13. So you know f1, you find out f12, the force at 1 due to 2, similarly force at 1 due to 3, and find the resultant of this two vector. Yes or no? So you will get the force at 1 due to 2 and 3. So guys, there could be multiple charges or there are n number of charges. You need to find the overall force by using these formulas. Okay, so you just F1 is not, I mean the overall force at 1 F, let it is F1 is equal to F12 plus F13. You just add it, the both the forces. Okay, so you find 1 by 4 pi epsilon naught, both the cases are same, so just take outside 1 by 4 pi epsilon naught into, you find here in the first term you find q1 into q1 into q2, but here you find q1 into q3, so q1 is common to both, so can I take q1 outside? So just take q1 outside, yes or no? Now this is inside, you find what? q2 by rq. R also is constant both the case, guys, so take rq outside, I mean outside rq, then what it becomes? Now q2 into what? R, yes guys, r2 minus r1 in one case plus q3 into r3 minus r1 in other case, yes or no guys? Similarly guys, you can able to, I mean there are 100 or 1000 charges are given, and if the question is to find the force on one charges to do all other, you can able to find easily. Okay, so this is all about the superposition principle and how to get the force on by applying the superposition principle.